Okay, so yesterday we talked about the first shale revolution and how it basically gave the United States top-level energy independence in natural gas and oil. Today we're going to talk about the second shale revolution, which is what we did with that. Crude by itself is of limited use. If anything, it's a big negative. You have to turn it into something else. And so the second shale revolution largely is about building out the industrial plant starting in roughly 2013 to 2017 in order to massively expand the footprint of the American refining industry. And we added huge amounts of distillation capacity based on whose numbers you're using, somewhere in the equivalent of 6 to 7 million barrels per day of oil and oil equivalent, to take all this oil and all this natural gas and to turn it into other things. Now, natural gas you can use as a power plant fuel, and it is the single largest source of electricity in the country, somewhere between 30 and 40%, based on which state you're in on average. And that has broken the connection between the United States and coal, which for a long time was our largest source. And so that switch by itself made the United States the country on the planet that had reduced its carbon emissions the most in relative terms on a sustainable basis. Now, there is more to it than that because it has also set the stage for the green transition. One of the big problems with solar and wind is, as you know, the sun doesn't always shine and the wind doesn't always blow. And so you need to have another source of energy to step in when green tech cannot deliver, especially if you're not in a place like West Texas where the sun is bright and the wind is strong. The best fuel source for that we have discovered so far is natural gas, because a combined cycle natural gas plant can spin up and down in as little as 10 to 15 minutes, whereas a coal plant can take up to 8 hours, and like a lignite plant, like what they use in Germany, can be 3 to 4 days. As a result, the Germans have actually seen their carbon footprint go up despite spending over €1 trillion on green tech and transmission. And all of this is a side effect. I'm sure that the frackers who put all the natural gas in the system weren't really thinking about natural gas and the green transition when they were doing their work. The second thing to keep in mind is, for the most part, natural gas is a waste product within the shale sector. It doesn't earn nearly as much on the open market as, say, oil or liquefied petroleum gases like propane do, and it often comes up as a byproduct or co-production, and so it's typically sold into the system at a loss. So not only has the shale revolution made the United States the single largest producer of this stuff and user of this stuff, it's at a price point that is significantly lower than everyone else, which is one of the reasons why the debate around things like the green transition in the United States actually hasn't been nearly as rancorous as you might expect, because the math has been a lot easier to do having that backup fuel. It's all part of the second shale revolution. And of course, there's more to it. Something called ethane often comes up as a byproduct of natural gas production. And ethane is a chemical that's a little bit different from methane, has an extra carbon molecule, and you can use it as the base material for any number of chemical processes. For example, the creation of things like methanol or butadiene, which provides a whole product suite that includes things like fertilizers and plastics. And so the United States has become the largest producer of all these intermediate products as well. But the same happens with oil. There's more to producing oil than simply making diesel and gasoline. You can make an intermediate product called naphtha, which goes on to make everything from bowling balls to insulation to diapers. And the United States is now the largest producer in all of those as well. This second shale revolution has seen a tripling of investment into the space of industrial construction to bring all these refineries and chemical plants online. And we're not done with the second shale revolution yet. One of the freaky things about oil is it's not all the same. You have different grades based on contaminants, and you've got heavy sours, which is what most of the American petroleum complex is designed to run on, and then you've got light sweets, which are very easy to refine, but our understanding back in the 70s, the 80s, and 90s is the world had run out of that. Well, everything that comes out of shale is light sweet because it's trapped at the moment of formation. It never migrates through the rock strata. It never picks up mercury, the sulfur, or anything else. And because of that, we actually have a massive oversupply of light sweet in the country to the tune of 5 to 7 million barrels a day of crude. Well, the final stage of the second shale revolution will be building out the processing capacity to process that as well. Now, the United States is already a net exporter of pretty much every energy product. And as we build out the refining complex in order to take advantage of this local surplus, we're also going to become the world's largest exporter of pretty much every energy and energy-derived product as well, and that's probably all going to go down in the next 5 to 6 years. And that sets the stage for the third shale revolution, which we'll talk about tomorrow.